In this video, we're going to talk about composition of functions. So this is a topic from algebra, right? It's one of the ways in which we can combine functions to make new ones. So if f of x and g of x are functions, and with some other conditions there that I won't mention, but the composition of f and g is defined to be the function f and then this little circle here, g, f of g. And the formula is given over here by f of g of x. Okay, so that's how that notation is read over here, f of g of x. And what this is you are literally plugging in the function g of x into the function f there. Okay, so most of the time people are fine with plugging in numbers into functions, right? That's pretty straightforward. But here we are taking a function in a sense and plugging it into f. Okay, so what we want to do here is just practice putting together f of g, right? Just so you remember how that works. What we really want is for you to be able to recognize a function that's built from composition of functions. That's really what we're going to need. So, but before we get to that, let's just take a look at a few examples here where we're building f of g here. Okay. So I have f of x equals x squared and g of x equals x plus 2. I want to find the composition of f and g, right? F of g here. All right, so there's the formula for the definition of f composed with g, right? And I know what g of x is equal to here. G of x is equal to exactly x plus 2, right? So over here I have f of x plus 2. And so what that means is, hey, go take a look at the function f over here. Everywhere you see this variable x, you are going to plug x plus 2. So if you look at the formula right here, right, the formula for f is x squared, right? And so what I'm going to do is rewrite that formula, but with the x taken out, right? So if I took out the x and just had these parentheses here to hold the place of the x, right, then what I'm going to do is I'm going to take this stuff inside here and I'm going to plug it right into those parentheses right there. So when I do that, that is what I would get. Okay, so f of g of x is the function x plus 2 quantity squared here. Okay. Next example. All right, in this example, f of x is equal to the square root of x, and g of x is this rational function, x plus 2 over x minus 1, and I want to find f of g. So again, it's pretty much the same steps right here. We're going to start with the definition of the composition, right? F of g of x. Okay, and here we know that g of x in this example is equal to x plus 2 over x minus 1. So from here to here, I am just replacing g of x with what it's equal to, x plus 2 over x minus 1. Now, looking at what this is telling us to do, right? It is saying, hey, go to f over here, and everywhere you see this variable x in the formula for f, right, I want you to plug the function x plus 2 over x minus 1. Okay? So the formula for f of x, right, is square root x. And here, just think of this as I popped out the x. I took the x out, right, and in its place, I am going to substitute this expression inside here in parentheses. So when I do that, right, that's what I get. Okay? And so that is the function f of g of x, or f, the composition of f and g. That's what that is. All right, next example that I have here, right, f of x is the polynomial 3x squared plus 4x plus 1, and g of x is equal to x to the 5th. I want to find f of g. All right, so here's the formula again for f of g, and again we know exactly what g is equal to. It is equal to x to the 5th power, right? G of x is equal to x to the 5th power, so I just replaced it here. And so now what I'm going to do is go to f, right, and everywhere I see an x, and here there's 2 spots where there's an x, and each one of those spots I am going to plug what's inside parentheses here, x to the 5th. So there is the formula for f with the x's removed, right? It was 3x squared, right? So I took the x out of here, 4x, took the x out of here, and in those spots I am going to plug what is inside parentheses in here and in here. Okay. All right. So that's what I've done, right? And of course here I can simplify that out slightly, right? X to the fifth raised or squared, right? When I have a base and a power raised to another power, you multiply the powers together. So that's going to wind up to be 3x to the 10th power plus 4x to the 5th plus 1. Okay. All right, so hopefully that seems familiar to you and you are pretty comfortable with composition of functions, because what we really need to do are these next few problems here. Okay, so these are sort of the reverse problems. Here, right, I have a function h of x and it's equal to 5x minus 2 to the 7th power. Okay, I want to find two functions f and g, right, such that the function h is f of g of x. Okay, so this is sort of the reverse problem. Here I have the end result, right, of composition of two functions. I want you to name the pieces of the composition of the two functions there. All right, so there's many different ways in which this could be accomplished, right? But this way that I'm about to show you is more along the lines of what we'll need in the next rule that we'll talk about, which is the chain rule. So in this situation, what you want to do is pick the inside part to be g. So in this case, g of x would be 5x minus 2. You can see that that function is clearly inside, right, the parentheses here. So if there's sort of a natural inside part, a lot of times that is a good choice, right, for g of x here. And later on in the subsequent videos, you'll hear me talk about the inside part, right? And so that's pretty much what I mean. I'm referring to the inner function, right, in the composition of two functions here. All right, so g of x is equal to 5x minus 2. And so next up, right, what we want to do is figure out what f of x would be, and it's essentially the reverse of the first few examples that we looked at, right? So start with the end result right here, and we've already picked g of x to be the inside function, the entire inside part right here. So think about just popping that out, right? I pop out the 5x minus 2, right? And here I have a blank in there, and then just replace that wherever you popped it out by just an x right here. So this function would be f, that x to the 7th right there. So f of x equals x to the 7th, and g of x is equal to 5x minus 2. This function up here, h, right, would be the result if I took 5x minus 2 and I plugged it in for x, right, into this function here. I would get exactly this function. So this is the composition of two functions, and this is sort of the process that you'll have to be doing when we talk about the chain rule. Okay. So a lot of times when we refer to the chain rule, I'll refer to the inside function and the outside function. Here, the inside function would be 5x minus 2, the g of x, right, and the outside function would be x to the 7th. And when we're going to apply the chain rule, that's what we will be doing. So let's look at a couple more of these. All right, so same setup here. Here I have h of x equals the sine of 2x plus 1. Right? So there's a clear inside part in there, right? That inside part is 2x plus 1, so I'm going to pick g of x to be equal to 2x plus 1. Okay. And then I need to find what f of x is, right? So start with the original function there, and then 2x plus 1 was the inside part, so I'm going to remove that. And when I do, right, you can just kind of imagine it would look like that. And then wherever I popped out the inside function, I'm going to replace it back with an x. And really that's sort of the opposite, right, of what we were doing in the first three examples. Here, in the first three examples, we were replacing x by some function, but here we're sort of working backwards. So f of x in this case would be sine of x, and g of x would be 2x plus 1. This function h is literally built up from taking 2x plus 1 and plugging it in for x into the sine function. So Later on, right, you'll hear me say that 2x plus 1 is the inside function and sine of x is the outside function. All right, one more example with an exponential function, e to the x here. And here I have e to the power tan inverse of x. So these are a little bit more difficult sometimes for people to get a handle on because there's not a natural looking inside part like in the previous two examples. When you have an exponential function like this involved in the composition of functions, the inside part, generally speaking, is the exponent up here. Okay, so that's what I'm going to do. I'm going to pick g of x to be the inside part, the exponent in this case, so g of x equals tan inverse x. Okay. So then once you've identified the inside part, right, you can just replace that inside part by just x to identify what the outside part is. So I had e to the tan inverse x, right, pop that out, and I just put those parentheses there to hold that space there, and then put an x back in there in that space. And so the outside part, or f of x in this case, is e to the x, and the inside part, g of x, is tan inverse x. So this is a skill that you really have to be good at in order to use the chain rule, which is the next rule that we will talk about. So this is good practice for that rule.